Hi, it's Jan Beta, and this is something very special. It is an international collaboration of international retro YouTubers. I am doing something like this for the first time. I think the other people involved are, some of them are a bit more experienced, some aren't. So the challenge goes like this. Chris, aka Perifractic, posted a video about him making an Apple IIe into what he calls a PIIe, which is it is the Apple IIe case that was empty when he got it, and he built in a Raspberry Pi and installed the RetroPie software on it, so he can have an Apple II emulator. And he also used a little dongle to use the internal original speaker of the Apple II, and he connected the keyboard. And then his idea was to challenge someone else to take this project on and bring it to another level. So he challenged me. You might have seen his video. I'm going to link it in again. Yeah, basically what I'm going to do, I'm going to show you in a second. The idea is that I'm going to send it on to another YouTuber at the end of this video, and the other YouTuber, who I'm not gonna disclose yet, is going to send it on to yet another YouTuber, and then, yeah, I think then it's going back to Chris, that's the plan at least, and Chris is going to give it away to someone. And yeah, I think that's quite a nice little idea. Yeah, so let's take a look at the little Apple PIIe and see what we can do. I already have an idea because, yeah, right from the start I couldn't really use it, so let me show you. Yeah, so here it is, the Apple IIe, or rather the Apple PIIe. It is a huge machine, takes up most of my little desk space here. This is quite convenient, it just lifts off back here so I can open the lid here. So here's what's in here. The little Raspberry Pi, of course. This is an adapter for Apple joysticks, 9-pin D-sub connector in the back there. That can be connected via USB. This is a little USB hub to have all the connections. This is a keyboard adapter. Retro connector, Apple IIe, revision 3, it says on there. There's a USB cable. This cable goes to the keyboard. Of course, there's power supply cables coming in. And there's the first problem I have with this, because these are these tiny American plugs. And I'm in Germany, so we use the Euro plugs, which are these ones. So what I'm going to do is to get rid of these, because they are both 5 volts for the Raspberry Pi and for the little USB hub thingo. I'm going to get rid of these and replace them with a juicy power supply and put one of these connectors in the back there. So this is going to work for voltages across the world, so it can be used by whoever wants to use it. So I think what I want to do is to make a little faceplate, or rather back plate, for this opening here, which I guess holds the original power supply, if there's one in there, which there obviously isn't. So I think I'm going to make a little plate to fit this and add a connector and a power switch. And for that purpose, I think I have to move the little Raspberry Pi, which is hot glued to the bottom casing here, a tiny little bit. So I'm going to put one of these in, as I said. This is the connector that I think most countries have cables that can connect to this. And I also bought this switching power supply by Meanwell. which is a pretty juicy one. It's a model RS255, which can handle 100 to 240 volts AC input and outputs 5 volts at 5 amperes, which is plenty for our purpose, I think. So yeah, and it also has this nice form factor, and it has some screw holes on the bottom there and on the side that I can probably attach to the case in some way or the other. So I'm going to work out where it goes and then connect this to the input and connect the output terminals to the USB cables that supply voltage to the Raspberry Pi and the USB hub thingo. So, well, let's get started, I guess. So I think the most reasonable thing for the power supply is to sit somewhere. Yeah, it should sit where the Raspberry Pi sits, really, I think. So it's not too far from the mains socket there. So probably what I'm going to do first is to try to remove the Raspberry Pi. I think I'm going to heat it up because it's hot glued in there. So I'm going to remove these connections here first. So I'm removing the little SD card to keep it safe. That's a 4 GB Kingston card. Nice. Kind of old school, but yeah. I think 4 GB is plenty for these old systems that these emulates. I think I'm going to use a cloth iron from the bottom side here to heat up the hot glue and hopefully get it off. Okay, let me get the iron. So I got the iron set to maximum heat. I rarely ever use this, so not the type of person who usually irons their clothes. So I'm not very worried about it getting dirty or something like that. Hope I don't damage the case in any way. So let's see. Ironing an Apple II. So let's see what it does. If we can somehow. Okay. Need some heat transfer here. There we go. That was kind of easy. Actually, that worked really, really well. Wow, that was very convenient. So, the Raspberry Pi is out. Here's the large blob of hot glue. Then we might be able to pry off even here. But I'm a bit afraid to take the components off there, so I'm just gonna leave it on there for now. So now time to work out where to put this. I think maybe it's a good idea to put it somewhere like so, I guess. Can I still reach? Yeah, the screws come from this side, so I can conveniently place it in the corner here and still reach the screws easily. And probably maybe the Pi can go here or something, so it's out of the way, and I can make a little plate there. I think this might just be a good idea, and Chris's signature is still visible. That's of course the most important part. So this is also glued in, by the way, but that's not a problem for my mod here. So let's work out a little plate to go in here, I guess. So the main problem for fitting a plate here is it's bent inwards a bit, so it probably admittedly I've never seen an Apple II from the inside, so I don't know what originally goes in here, but I think, at least I've never seen one live. I've seen pictures, but I don't really know how this supposedly power supply is attached here. So yeah, I think I'm going to work something out. I bought some aluminum sheets, so I can probably bend it in a way that it's going to fit in here. And I also need to make a little bend to cover the bottom side of the case, I guess. Yeah. That's going to be the main challenge, I think. I think the electrical part is pretty straightforward because this is such a convenient device, because it has these screw terminals that you just attach the input, live, neutral, ground, and you get your 5 volts from the V- and V+. And there's a little adjustment pot that you can adjust the voltage with as well. Very convenient thing. And these are pretty good. They have overvoltage protection, they have short circuit protection, they have thermal protection, they have an input fuse. Not really sure if they have an input fuse. Maybe we should look into the data sheet and add an external fuse, I guess. The capacitors in these are Nippon Chemicon, so high shelf stuff. So here's the data sheet for the RS25 series by Meanwell, and here's the nice features it has. It has a short circuit, overload, and overvoltage protection. It has an LED indicator up, we don't really need that. It also has very low ripple and noise. Working voltages are from 88 to 246 AC and 125 to 373 DC volts. And it can also work for the different frequencies of the AC. Yeah. And it has an efficiency of 78.5%, which is plenty. So this is a pretty good power supply. And it should work fine for our purposes, but it doesn't seem to have a fuse on the input. So I'm going to add a fuse as well into my little backplate there. So what I want in here is a connector and a power switch and a fuse. So let's see how we can work that out. So I think I'm going to just use a piece of cardboard to mock this up. And I think what I'm going to do is to attach it from the outside, because it's much easier. I think I'm actually going to use these to save some space, because these have fuse holders already built in. These are clip-in connectors there. So let's mock this up with some thin cardboard thing here. Okay, so this is basically what it's going to look like. I'm going to make a little bent aluminum thing and cut it to the size so we can fit it in here. And then I'm going to screw it in the corners here. And there's room for one more screw here, I guess. And it's going to be... yeah, it's going to look alright, I guess. And we have room for this thing and a switch, I guess. Yeah, should put the switch here, I guess. I'm going to mark the size of the cutout on the inside here with a pen, so I can estimate the dimensions that we're going to use for these things. Ta-da! So this is what we have. And there's not much room for anything else, so it's a good idea to have the fuse holders on the IECC connector. This is called. Pretty similar to the IEC serial connection the Commodore 64 uses. But these are IECC, actually. Got a switch. This basically goes something like this, I guess, which will fit fine. Something like this. So the cutout for the switch needs to be smaller. This is that's why you mock things up, I guess. This needs to be a bit smaller, so I'm just going to use some tape think on the top here. So like 2 millimeters less or something. Yep, that's better. Okay, looks pretty convincing to me. Let's see if it fits into the unit there. Okay, let's see if this goes in there some way. Yeah, that's not too bad, I guess. This might just work. So let's try to build this in aluminum. Which is another challenge because I haven't worked with aluminum that much. Or aluminium, whatever you want to call it. Here in Germany we say aluminium. So here's a nice sheet of aluminum. It's 0.8 millimeters thick, which should be alright if we screw it in 3 different places. So it's going to be easier to work with than a thicker strength. This is going to be strong enough, I guess. So yeah, let's try and build this with this. So what we supposedly should be able to do is to just put our ruler here. Oh, and cut not into the ruler but into the aluminum. Probably, possibly, break this. So, okay, like this. And then we need to cut out our little cutouts there, and I don't really know how to do that. I think I'm going to use the drill. Okay, so that was quite a pain. Okay, the little moment of truth here. Let's see if we can fit this in here. Ta-da! That's kind of a relief. So there's probably a lot of you people who can do this kind of thing a lot better than I do. But rest assured, there's a lot of love going into this. I'm rounding the corners a bit, so nobody's going to hurt themselves. That's the rounded corners look that Apple has maintained throughout their history, I guess. So I also added some electrical tape on the back, just in case. So I am going to use self-tapping screws. Okay, I'm drilling into an Apple IIe. Sorry, Woz. I totally broke my drill. There was a steel drill, by the way, so I don't really know. And I totally broke the... I broke this little door here. I think my drill was borked before. Ah, there we go. Okay. So that works kind of. Man, that could have been easier. Okay, so that's in. And now there's this gaping hole on top here. I think I'm going to put some plastic on there or something. So here's how this looks now. It nearly looks like I planned it to look. Minus this broke, but yeah, the plate I designed works as I intended. So I got these gray PVC sheets, which I use from time to time for everything basically, and it won't look that bad if we put them in there, I guess. So let's gonna do that. Okay, so this is what it looks like now. It's not too bad, I guess. Yay! Okay, on to the next step. The inside. So I made a little test fit of the power supply, and I think it's going to go like this. The switch just fits in here, so I should probably put a piece of plastic behind there. Something like that, and yeah, the power lines are going in here and out here, and the PIIe is going to sit somewhere in the middle, I guess, because it's the heart of the whole machine. This is going to be used to put the HDMI cable or the composite cable out. So for the connections to the Raspberry Pi and the little hub, I'm just going to use the cables from the power supplies and just cut them off because you won't need those anymore. So this one has a black and white wires. I don't know which one is which, so I'm going to check. The other one conveniently has a red and a black wire. That means most likely that the red one is positive and the black one is negative. So this one has a clear and white cable in it. Don't really know which is which. My guess is that the clear one is the negative. So I have the power supply, the bench power supply set to 5 volts. So let's see, let's connect something. Maybe something like this, which is a power bank. And yeah, as you can see, seems to work. The LED lights up. So the white one is positive. I'm probably going to mark this in red. So we have determined that. So we can use this cable to power the PIIe. Let's see about the other one. So this is the other cable. So I guess the red is positive and the black is negative. But I'm going to check anyway. This should be center positive. It's marked on the little USB hub. So we can just take our little plug and put one of our probes in the center there, which should fit nicely. Yes, it does. And then we should have connectivity with the red wire. Yeah, so the red is positive. So we just have to connect this to our little power supply in the right polarity, and we're good to go. And then we of course have to connect the mains, which is another story. So these can totally go. So because I want to connect these in parallel, I'm just gonna solder them together, I think, which should be a nice idea to keep them together, hopefully. Looks a bit strange, but it's gonna work. So for the mains, I'm using actual cable that's salvaged from a mains cable. This is the ground. I don't know, the color codes differ a bit internationally. So this is the German codes. This is ground, green and yellow. This is the brown wire, that's the live wire, and the blue one is neutral. I think it's slightly different for different countries, but I'm using, obviously I'm using the German way to do it. So I am tinning these, and I'm going to solder these to the switch, and then I'm going to add a heat shrink and make it all nice and hopefully safe. By the way, this isn't going to be according to any norm or anything, because I don't think any of the participants so far is anything like a professional electronics person. So this is all at our own risk and at your own risk if you get this at some point. Guess we're going to get away with it. If not, we're going to end up in jail, which won't be fun, of course. That's our life, that's our neutral, and that's our ground. So this is ground. This one is going to be going through the switch as well. So this is going to be a shorter wire from here. So heat shrink tubing for extra added safety. So this whole assembly goes in here. So I shortened these wires and am going to connect them to the live, the neutral, and the ground. So the ground is properly connected, this is all properly connected. Then I'm going to connect the output. Look at the beauty of this. Very, very beautiful. So this goes like so, and I think I want to put the little plastic lid back on, if I can find it. There we go, I found it. Now it goes back on to protect this from accidentally being touched, I guess. So and this one goes in the USB hub. Okay, put in some 1 amp fuses, and I'm going to also put in a cable tie to secure this, so you can't pull it out of the case accidentally, which would be pretty dangerous, obviously. So there are fuses, the power supply is connected. This should just work, I guess. Should probably test this. And for testing it, I'm going to connect it to the mains, and I'm going to measure the voltage on here. Now this is live, so I'm turning it on and see if it burns. Okay, it's not burning. That's good. So this should be 5 volts. And it's 5.1 volts. Yeah. So now I'm going to connect something that needs 5 volts, like my ebook reader here. This is Angela Davis, by the way. And I think I'm going to turn it on and see if it lights up. Which it does. I could charge this from this little connector now. Which is, of course, the whole purpose of this. No, it isn't. This should go into the Raspberry Pi and make this whole thing come alive. So I don't have the SD card connected, obviously. But we are going to make a little smoke test, I guess. So, okay, connecting the mains, turning it on. And the Pi comes on, and the little... Don't know if you can see the lights. Can you see the light on the Pi? Yeah. Power. So this works as intended so far. Let's test it. I intentionally left the cables a bit longer so the other guys can work something out. So I have the SD card connected back in, I have the HDMI out connected to my monitor there. Okay. Yeah, so this actually works. And it does some sound too. This works, which is great, of course. So, restart, quit, shut down system. Yep, shut down. So now it's shutting down, really shutting down completely. And we can turn off the computer. Ah, this is pretty cool. Pretty elegant, I think. So, and obviously, as this is a hobbyist project, we're going to use a lot of hot glue. Okay, the final step is going to be, I'm going to make a little sticker that tells you which voltage range the input has and which frequency range and the maximum power consumption, which is the maximum power consumption of the Meanwell power supply. So it's never going to be that much. It can go that high. So I think I just print it out and glue it to the back there. And that's the finishing touch. So now people are going to know what they can connect to this power supply there. So, and obviously I have to sign this too. So I'm going to sign it next to my work here. Oh, and as Apple used to do, and I think they are still doing it, and I happen to have some, I'm going to throw in these Apple stickers. Yeah, as you've seen, I've tried my best to bring the Apple PIIe to the next level of awesomeness, maybe. So I think the power supply was a reasonable thing to do, given that this is going to be an international collaboration and it's going to be given away to some person somewhere in the world, and mains voltages vary a lot. So I think this solution will make sure that everybody can use it, basically, hopefully. So now the next step is to challenge another YouTuber to send this to, and yeah, I think I am going to challenge my friend Mark, who was very supportive of my stuff right from the start, and he started his YouTube channel, and he's better known to the community as Mindflare Retro, I guess. So, Mark, over to you in Canada. Are you going to accept this and try to bring this to the next level?
Jan, thank you very much for the nomination, and I humbly accept. And I'm a little bit scared.
Okay, that's awesome. Thank you very much. So I'm going to send this to you and see what you can make with it. So, you other guys, thanks for watching. Hope to see you all soon. There's going to be links to the next videos, to the previous videos in this collaboration in the description below, and I'm also going to post links on my Patreon, my Twitter, all the social media stuff, and I think there's going to be some more video about this when it's all finished. And yeah, I'm sure you're going to watch the other YouTubers involved in this as well. Highly recommend their channels that I linked in across this video, I guess, in the corners and in the description also. So go check them out. If you want to support my work, as usual, feel free to give this a thumbs up, give my other videos thumbs up, subscribe to this channel, there's a lot more coming. Yeah, basically, if you want to support me, you can check out my Patreon, I already mentioned that. Gonna link that in this corner there. And see you all very soon. Thanks for watching, I'm Jan Beta. See you next time. Bye.